I've come to East Yorkshire to see a collection that to some might not be the prettiest, but for our collector, it's been his passion for over 25 years.
I'm interested in machines and things that go whir, you know, and anything goes round or, you know, makes a noise or whatever, it's interesting.
55-year-old Jim is a professor of neural computation, and he collects obsolete computers, most of which don't even switch on.
It's a bit of a crazy passion, you know, you just get hooked. Because every new machine that comes through the door, you know, wow, you know, look at the size of it, look what it's got in it. Hey, it's got that sort of processor. And also just the look of them, they look great. Smart, really sexy. Hi.
Hello, Jim.
Jasmine.
Nice to meet you.
Jim's collection is stored in 4 outbuildings, but these aren't your average garden sheds.
So these are the sheds?
This is all given over to your collection?
Yep, all of it.
It's no wonder you don't have it in the house. It wouldn't fit in the house. Wow. This is quite a setup you've got here, isn't it? Oh my goodness, look at these.
Jim's collection started in 1986 and represents computer development over the last 100 years.
Being in academia, you know, you can be seen as being a bit bonkers. So I didn't tell anybody about the collection for years and years and years. I just collected it quietly because I knew it was a bit odd.
He has over 1,000 computers in his collection, including this one that was donated by a nuclear power station.
So yeah, this is designed in about 1959 in Wilver Nuclear Power Station, looking after the nuclear power station. And it ran from 1966 to 2003 non-stop. Possibly one of the longest running computers.
The mind begins to really boggle when you think that this monitored a nuclear power station for all those years, and yet is probably less powerful than
a watch.
A watch. Really?
Yeah.
Jim has the largest private collection of historic computers in the UK, but his passion began when he was just a child.
I'm dyslexic, which was a problem at school. And my mother was told that get him interested in something. So there was an old radio in the cupboard at home, so I took it out the bottom of the cupboard and took it all apart, saying I was going to fix it. And I chopped all the components out, put them in neat little piles, and that was it. It never worked again, but I was hooked.
By the age of 17, Jim had built his first computer, and he's continued to achieve great things.
I'm a professor of neural computation, so I'm known for neural networks, which is basically how do you make computers work like the brain works. Computers have been central to what I've been doing all my life. So this is the cool computer. This is my everyday job, is designing new machines like this.
So you built this?
Yeah. You know how hard it is to add memory to your computer? Well, there's this, you just do that. You want to add a bit more memory? Another processor?
So what is the idea behind this?
Make computers better. We find new ways of building them.
Do you think having this collection and exploring these old computers has helped you to invent something like this?
It is a direct result of the collection.
One of the most impressive rooms is the one that's home to Jim's supercomputers.
This looks like where you keep all the monsters, all the beasts.
Yeah, this is our machine room.
Supercomputers were introduced in the 1960s and are the fastest type of computer. They're used for very specialised applications that require immense amounts of mathematical calculations, such as weather forecasting and nuclear energy research.
This is one computer?
Yeah, so it's about 22 years old.
Oh my goodness.
It was a national supercomputer. It's the most powerful computer you can get, basically, at the time. Weighs about 5 tons.
5 tons?
Yeah. But your average smartphone, 100 times the power of this machine.
You could have 100 of these in your pocket.
Yeah, you do.
Basically.
You do. And it cost about £2.5 million. But the amazing thing was, I worked out, it depreciated at £16,000 a week.
Oh, no.
These computers were the cutting edge of technology in their day, but are now out of date and would have ended up on the scrap heap had it not been for Jim.
This one was probably used for sort of chemistry and that sort of thing, you know, for working out new molecules for drugs, that sort of thing. The great thing about this machine is the button at the top.
Right, that just looks like, imagine somebody...
Well, it's a reset. It is a reset button.
It's a reset button?
Yeah. So what people used to do is to come in and say, well, how's the computer going? And that would switch it off.
Yeah, switch it off.
So what they did is they made little protectors for them out of drain pipe. There you go.
So that people wouldn't accidentally reset your computer right in the middle of your really important work.
I know, it's just wonderful, isn't it?
It's taken Jim a quarter of a century to amass over 1,000 computers, but he's now starting to worry about their future.
I have Parkinson's disease as well, diagnosed about 4 years ago. My consultant for my Parkinson's disease says, some people said it's the best thing that's ever happened to him, and I thought, what best thing that ever happened to them? How can that be? But I can see why, because you basically sit back and say, right, I'm going to focus on the things I really am passionate about, because, you know, you never know how long you got, sort of thing. So it's the computer collection and my research.
Jim is finding it harder to manage his growing collection, so a few of his friends who also share his passion help out.
Jim tells me that you guys are his shedders. That's what he calls you.
Yes, that's
Is that right?
Yes.
So what's the idea behind it? Why do you guys come down here?
As you can see, there's rather a lot of stuff here, and it takes quite a bit of work to move everything around and organise it all, and hopefully get some of it going. We've not had all that much luck with that, but we're trying.
Everybody has to be a little bit daft, I think, to come and do this, but it's good fun. And, you know, who could throw away this equipment? It's beautiful.
I mean, guys, convince me, isn't this just a load of old, defunct, out-of-date technology?
Well, if you can imagine when steam engines were being phased out and everything was moving over to diesel, then people would think, oh, these things are huge, they're useless now, we'll just get rid of them all. But then look at all the heritage steam railways that are going now and people restoring the engines. It's exactly the same thing.
Jim would love more people to be able to enjoy and appreciate the collection, and hopes that one day it will be open to the public.
The idea is to not so much open it as a museum, but as a learning centre. People can come along and see, you know, what's happening, get inspired by it, and create the next generations of computing.
So in a way, the main idea behind this collection, or the future of this collection, is to get as many people benefiting from it, accessing it, learning from it, enjoying it.
And that would be fantastic. Really, really good.
I want to help Jim throw open the doors to his hidden collection and see if we can get him the recognition he deserves. While one collection could be getting its time in the limelight, another is up for an audition.
Computer collector Jim is also keen for his efforts to be shared and enjoyed by others. But far from their many and varied uses today, decades ago they were changing British history. I've come to the National Museum of Computing in Milton Keynes to discover more.
The story behind one of the world's first electronic computers is one of intrigue, true British determination and ingenuity. A machine shrouded in secrecy for decades. This is Colossus.
A machine that helped change the destiny of World War II and mankind. The year was 1940. Allied listening stations were picking up radio chatter from across Europe. Hitler's famous encryption machine, the Enigma, had been triumphantly broken by Alan Turing and his colleagues, so now we were able to decipher the cryptic messages sent between troops across the continent. But we weren't able to decipher the codes Hitler used to communicate with his inner circle, produced from a machine known as Lorenz.
The challenge facing mathematicians at Bletchley was to break a code with a staggering 1.6 billion possibilities. And unsurprisingly, initially they were stumped.
With each message being individually encrypted, it was thought the code couldn't be cracked, but eventually the British got a lucky break. A German message using one of the uncracked codes was sent twice. The second message used abbreviations. However, the German operator sending the messages slipped up, and failed to change the encryption setting. British codebreakers compared the abbreviations with the original message, and within a couple of months, mathematician Bill Tutt had established just how the Lorenz machine was encoding them. Now Britain could decipher communications sent by Hitler's high command, but there was another problem. By the time they deciphered the messages, the events had been and gone.
The breakthrough would come from an unlikely candidate, an engineer and electronics whiz called Tommy Flowers. The son of a bricklayer from Poplar, he had been working as a General Post Office engineer in one of their research centres since 1930.
But underneath all that rough and readiness was one of the greatest men in British history, and one who had helped turn the fortunes of the war. Flowers suggested building an electronic machine that used 1,500 valves to decode thousands of characters every second. But previous devices using valves had been unreliable, often breaking down. No one had ever used so many, and no one thought it would work. Flowers was convinced and stuck to his guns. He spent the next 11 months with his engineers building the world's first electronic, digital, programmable computer. No one had seen anything like it. They dubbed it Colossus. The machine did the job, and by the end of the war, the British had 10 in operation, which gave them an ear on Hitler and his most trusted advisors, and was thought to have shortened the war by 2 years.
You're not alone if you've never heard of Colossus. Revealing the achievements of people like Tommy Flowers was deemed a security threat. It's only in recent years that declassified war documents have revealed the truth. The huge debt owed to these heroic mathematicians and engineers. Tommy Flowers received little recognition, but he should be remembered not only as the man who built one of the world's first computers, but also as the man who rose to the challenge to save his nation in its hour of greatest need.
Back in East Yorkshire, I'm helping Jim find a way to help others appreciate his passion for obsolete computers, which have so far gone unnoticed. We're hosting an open house, or should that be an open shed?
I know you were quite nervous about having lots of people in here and touching your precious computers, but when I was chatting to your shedders, all of you would really like this collection to be more accessible.
Yeah, it would be great to do that. I mean, what we've been trying to do is to set it up so we can start to see what's possible. You know, museums are great, but what we want to do is produce the next set of people that can develop machines like this, you know, and push forward. And by coming here and having a look at the machines, they can learn about them and go, yeah, I can do this.
Our first guests are a group of computer science students from the local university, along with their lecturer, Dr. Chris Bailey.
What do you think of this, seeing all these old computers?
I mean, it's fantastic to see Moore's law in action.
Moore's law? What's that?
The doubling of the number of transistors on a chip every 18 months. So that's how we have the same amount of computing power in our iPhones today that we have on these big mainframes from decades ago.
So Jim and his friends have put together a challenge for you all. You up for it?
We'll give it a try.
Yeah. Excellent. Well, follow me.
As I lead them through this TARDIS of technology, Jim has a surprise waiting that will hopefully get the votes of his first visitors.
That is the machine that Maggie Thatcher's election results were calculated on.
This actual machine?
That actual machine predicted the outcome of the election more accurately than anybody else. That's quite exciting, isn't it?
So what we're going to try and do today is to try and restore these two machines. Neither of them work at present. So what we'd like you guys to do is to try and get one of the machines to work, and then we will use that as a basis to restore the other one, so eventually we'll have both machines properly restored.
Feeling confident? Well, good luck, guys. Do you think coming here today and having a task like this is going to be beneficial to your students?
The opportunity to take apart a computer, or put it back together in this case, hopefully, is something that you don't tend to do very much. These days we have laptops and smartphones. It's not the sort of thing you take apart. Getting to look inside a computer is more of a rarity.
So is this a bit of a treat for them today?
Yeah, I think so, yeah.
And these switches tell you what the base address is of each card.
Okay. And that's set in a binary.
Tomorrow's computer whiz kids are loving this hands-on access to these old machines. But I've also invited along another group of tech fanatics that might actually be able to enlighten Jim on some parts of his collection.
Hi, Jim.
Hi.
I brought some people to meet you.
Hello.
They are from the Computer Conservation Society.
Britain's largest group of computer history enthusiasts are volunteers that spend their time preserving old computers, much like the ones that Jim owns.
What is the value in preserving these old technologies?
Well, all this represents the second industrial revolution. They're so easy to throw away when they become obsolete and a new version comes. So it's absolutely vital that this technology and the way things were done only 50 or 60 or 70 years ago are preserved.
So are you all feeling quite excited about what you might uncover walking around here?
Definitely, yes.
Do you want to go and explore, and then we'll see you afterwards?
With over 1,000 uncatalogued items to process, it'll be interesting to see what they make of the collection and see if they can shed some light on other ways to make it more accessible.
It's astonishing. It's so huge. One could spend weeks and weeks examining everything and saying, ooh, I remember that.
To my mind, you could have a selection of your machines publicly visible in timeline kind of display, easily assimilated, plenty of graphics, and that would tell the overall story of the computer.
I like the idea of a timeline. That worked very well.
Is it nice to have people here who really appreciate and understand your collection, unlike people like me?
Better to see people like you come, because prior to coming you knew nothing about this sort of thing. You're learning about it for the first time and doing what the collection's aiming to do, which is to, make you aware of the history of computing.
Jim's own history-defining computer has now been overhauled by the visiting students and Jim's friends. But has this new open house experience been worth it?
So, moment of truth. Ooh, sounds positive.
Would you like to press the light that says load?
Me? Yes. Do I get to press it?
Starts up, and here it starts spinning. Stand back.
What's going to happen? Is that it? Is that it's working?
Wait for the screen.
Oh. Hey!
Whoa!
Wow! Everyone, well done!
Fantastic, isn't it?
That's amazing.
It's great, isn't it? Wonderful to see them working again.
There's life in the old dog yet.
This is the first time Jim's computer has worked for around 15 years.
It's fantastic because we've got very few machines working at all, so to have one actually operating and the lights flashing, absolutely brilliant.
The question is, though, will I be able to send an email on this?
Probably not. Brings it to life when people come here and look at everything. It makes you want to do more of it. Inspire people and even people who don't know much about it. It's fantastic.
I know Jim wants as many people involved with his collection as possible. I think what he has here could be a fantastic learning tool and an innovative way for people of all ages to connect with technology.